All right, what's up, everyone? I'm actually filming this for the second time because it broke the first time. Well, I made a mistake the first time. So today we're going to talk about Earth rotating. This is important. Why? Because Earth rotates. That's one reason. So mainly think about things like this. So Earth rotates, and that dictates, rotates like spinning. That's going to determine how many hours there are in a day. So every time you look at your watch and you're like, oh, or your phone, and you're like, what time is it? Well, it is, the reason for the time is because Earth rotates. So let's go ahead, let's get right into this, and here we go. Okay, the actual motions of the Earth are based on the heliocentric model. So the heliocentric model is what we're using here. That is where the sun is the center. And we have two motions that are important to pay attention to. Earth rotates, which is its spinning, and Earth also is going to, and this, so the first one is rotation, and the second one is revolution. So revolution is the Earth going around the sun. This is obviously going very fast, the animation, because normally going around the sun is going to take a whole year. So revolution, orbit, going around the sun, takes 1 year. Rotation, the spinning, is going to be every day, 24 hours. So how does Earth rotate? Earth rotates east to west, or sorry, I just said totally backwards, west to east, one time each day. It's rotating around its axis, kind of like in this little pictures here, which is just an imaginary line. It's not like it's really there. And it's important, it's tilted at 23.5 degrees, 23.5 degrees. The period of rotation is going to be 24 hours in a day, and that's 15 degrees per hour, which we can figure out by using some math. So 360 degrees in a circle divided by 24 hours in a day gives you 15 degrees every hour. So why is this kind of important? Well, if you've ever called someone, maybe like I have a friend who has family in Sudan, he calls them, so they are, I think it's 7 hours ahead of us because they are farther to the west, and Earth rotates from west to east. So they've already had their morning time. It's 10 o'clock right now. They've already had their morning time. They're into the afternoon. Let's see, 10, 11, 12, 1, 2, 3, 4, 5. So it's like 5 p.m., they're getting ready for dinner. They're finishing their workday over there. And it is 7 hours because it's 15 degrees. So every 15 degrees is 1 hour. 15 degrees, 30 degrees, 45 degrees, 60 degrees, right? And until you get 7 hours of difference. So what would happen if Earth rotated at a different rate? Well, if Earth was spinning faster, it makes sense that the days would be shorter. And if it's spinning slow, then the days would be longer. So be glad it doesn't spin slower. I'm sure sometimes it feels like it does. So if the Earth rotated faster, decrease less than 24 hours. If the Earth rotated slower, you would have longer days. Okay, let's do a little quick thought experiment using your brain, imagination. Imagine you threw a paper airplane from the North Pole to the equator, right? It should just go straight down, right? Boom. But there's a problem. Earth is rotating, right? So when you throw it down, instead of it going kind of to here, your throw is still straight, but the Earth moved, so it's going to land over here. Okay, let's demonstrate that a couple more times. So here's a cool little animation to show you. You can see the white line there is showing you that your throw was straight, but the Earth moved, and so it's going to land in a different location. So instead of it, your throw is still straight. That's what the line's showing you. Like if you threw this little red ball, but instead of landing straight below you like you thought it was going to, it's going to land off to the right. Here's the evidence, or what we call that. The evidence of Earth's rotation is called the Coriolis effect. So it's the deflection or curving of planetary winds caused by Earth's rotation. And sorry, just distracted for a second. And when we're talking about the way they're going, you have to imagine you're standing on the pole. So we say in the northern hemisphere, the wind's curved to the right. So you have to stand where the wind is coming from and kind of like look that way. Okay, it's going to the right. And then in the southern hemisphere, it's curving to the left. So let's look at an example. So every time the wind, wherever it originates from, so here's the origination of the wind, it curves to the right. Oh, here's the origination of the wind, but you have to imagine you're standing at like the front of it. Oh, it curves to the right. Okay, down in the southern hemisphere, it's always to the left. Okay, you might say, oh, this one's going to the right, but no, you got to stand as if you're looking at like where the wind came from. Okay, it's curving to the left. Hopefully that makes sense. It's a little weird. Let's try this to maybe help make sense. So if the wind is curving to the right, it's always going to the right. You have to imagine you're standing in that little cross in the middle. So kind of like turn. Okay, so the next one's going to go to the right. So it should go like this down this way. Oh, yes, it does. Okay, this one curving to the right. Okay, boom. And the last one curving to the right. So it should go like this. And it does. I know, amazing. So another way we know that Earth is rotating is this thing called the Coriolis effect. Oh, sorry, the Foucault pendulum, some French guy. Okay. And what happens is, so if something is swinging back and forth, you'd expect it just to go straight back and forth forever, bloop, 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 you know, until it runs out of momentum. However, when they make this cool little, like large scale model, so it has to be big, what they notice is that it looks like it's moving. So you're like, oh, look, the pendulum's moving. But the pendulum is not moving. What's actually happening is the Earth underneath is moving. Okay, so they call this the Foucault pendulum. It's an interesting one because there are a couple real life models of this, but you'd think it'd be this big thing that you'd be able to find lots of models on. So I wonder if maybe it doesn't work perfectly. Anyways, something to look into. I'm kind of curious to know more about it. I've done some reading on it over the years, so you can check it out, Google it, see what you find. Yeah. So we're going to stop there for today. And thanks everyone for being here. And I will see you in class. And just keep up the good work. I know it's been a long year. I know that it's not always been fun. So, you know, thanks everyone for making it better. And I'll see you soon.